In this video, we'll be looking at the sum and difference identities. We'll probably split this into several videos to cover this topic. Sum and difference identities are also called the composite angle identities. And first of all, we're going to discuss why we need them, and to see that it's not, you have to be careful with the way that you apply these. So classify each statement as true or false, then explain your reasoning. So we are trying to decide, is sine of 90 the same thing as the sine of 90 plus the sine of 0 degrees? So sine of 90 is equal to 1. These are coming off of the unit circle. We need to know that. Sine of 90 is 1 again, plus sine of 0 is 0. Sine of 0, remember, we're looking at, on the unit circle, the y coordinates on the unit circle for sine. And straight up on the unit circle is 1, straight to the right on the unit circle, the y coordinate would be 0. So 1 plus 0, does that equal 1? Yes. So that one is true. So what we are suggesting here, or what's being discussed, is does this sine of 90 is, can I do this right here? Sine of parentheses 90 plus 0. And just say that basically we can distribute sine in here and make that true. Just do sine of 90 plus sine of 0. Is that the same thing as what I have listed here? And so far it has worked, so let's continue on. So this next one, cosine of 90 degrees. Does that equal cosine of 90 plus cosine of 0? In other words, can I just distribute in here and say that this right here is the same thing as cosine of 90 plus cosine of 0? Let's see. So cosine of 90, this is the x-coordinate on the unit circle. At 90 degrees, the x-coordinate is 0. And that equals cosine of 90 again to 0. Plus cosine of 0 degrees, the x-coordinate at 0 degrees on the unit circle is 1. So does 1 equal 0? No, it does not. So that one is false. We cannot do that. It's not the same as distributing cosine in there. We cannot do that. All right, let's look at these two over here. So sine of 30 degrees plus sine of 60, is that the same thing as sine of 90? In other words, can I distribute this in here like this and say that that's the same thing as doing sine of 90 degrees? Alright, so sine of 30 on the unit circle, 30 degrees, the y-coordinate would be 1/2, plus at 60 degrees, the y-coordinate is square root of 3 over 2. And does that equal sine of 90 degrees? The y-coordinate at 90 degrees is 1. So is 1/2 plus square root of 3 over 2 equal to 1? No, it is not. So that one is false. All right, one more here. So tan of 45 plus 45, can I just distribute tan in there and say that tan of 90, add these up inside here and say that's the same as tan 45 plus tan 45? Let's see. So tan of 45 degrees, the x and y coordinates are the same at 45 degrees, and tangent is defined as y over x. So tangent of 45 degrees is equal to 1, plus tangent of 45 degrees is equal to 1. Tan of 90 degrees, on the unit circle, it's y over x. The y coordinate at 90 degrees is 1, the x coordinate is 0, so that would be 1 divided by 0. Well, that's undefined. So does 1 plus 1 or 2 equal undefined? No, it does not. So that one is false. So what we have shown here is we can't just use the distributive property here when working with these trig functions. So what rules do apply? Well, it's all of these sum and difference identities here. So you'll notice it's not as simple as saying, well, this means sine of a plus b is the same thing as sine of a plus sine of b. You cannot do that. That will not work. You have to do what is shown here. If you want to find sine of two angles added together, you have to follow this process. And the same for cosine and tangent as well. All right, now let's apply one of these. So it says demonstrate that each identity works by substituting the given values for a and b. So we're going to be using the cosine sum identity here. And they tell us that a is pi over 3 and b is pi over 6. So obviously these are in radians. And we're going to substitute in the values. First of all, we write the identity out like this and substitute it in. So cosine of a is pi over 3 plus b is pi over 6, and that will be equal to cosine of a is pi over 3 times cosine of b is pi over 6 minus sine of pi over 3 times sine of pi over 6. Alright, so now we're going to evaluate, basically we're going to simplify some of this. So pi over 3 plus pi over 6, this is like 2/6 plus 1/6 is 3/6 with pi on top in the numerator, so that would be same thing as pi over 2. So if you add pi over 3 plus pi over 6, you'll get pi over 2. And that's equal to all of this again. I'm just going to copy it. So we're just showing now that pi over 3 plus pi over 6 is actually pi over 2. That's all we did in that step. And now we need to evaluate that. So cosine of pi over 2, the x-coordinate at pi over 2, so straight up on the unit circle is 0. So we're going to prove that this side over here equals 0. So cosine of pi over 3 is 1/2 times cosine of pi over 6 is square root of 3 over 2. Subtract from that. Sine of pi over 3 is square root of 3 over 2 times sine of pi over 6 is 1/2. So here we get, this part we get square root of 3 over 4. Subtract from that. Here we get square root of 3 over 4. So that in fact equals 0. So we have proven this, that this works because the left side is equal to the right side. So 0 does equal 0. Check, this identity works. Now we're going to work with tangent, and tangent is usually the most difficult for most students. So I've gone ahead and sketched out the first quadrant, or at least the pi over 3 and pi over 6 and pi over 2 part of the first quadrant of the unit circle, just to remind you what those values are so that we can identify the tangent values. Most students don't have the tangent values memorized, so we will need those, so I wanted to use that for reference. So we have, this is what we're asked to find, where A is pi over 3 and B is pi over 6. So we'll fill in the identity first. So tangent of A is pi over 3 plus B is pi over 6, and that's going to be equal to tangent of pi over 3 plus tangent pi over 6, just filling in pi over 6 for B and pi over 3 for A everywhere we see it in the identity. Tangent of pi over 3 times tangent pi over 6. Alright, so now we start simplifying a little bit. So tangent pi over 3 plus pi over 6 is pi over 2. So we want to show that tangent of pi over 2 is equal to all of this again. I'm not going to write that all over again. So let's copy that down, paste it here. Alright, now we need these values of tangent pi over 2, this one, tangent pi over 3, this one, tangent pi over 6 here. So I'm going to write those off to the side. So tangent pi over 2 is going to be equal to the y-coordinate divided by the x-coordinate at pi over 2 radians. So that would be, the y-coordinate is 1 divided by the x-coordinate is 0, so that would be undefined. So we're going to need that value. And then tangent of pi over 3 is the y-coordinate divided by the x-coordinate. So square root of 3 over 2 divided by 1/2. Well, if you flip and multiply, you get this, square root of 3 over 2 times 2 over 1. 2's cancel. You're left with square root of 3 over 1, or just square root of 3. Tangent of pi over 6 is the y-coordinate divided by the x-coordinate there, so that would be 1/2 divided by root 3 over 2. So that's equal to flipping and multiplying, so 2 over root 3. So the 2's cancel. We have 1 over root 3 coming down here, 1 over root 3. We need to rationalize that denominator, so we end up with root 3 over 3 for tangent pi over 6. So now that we have those values, we can fill those in the next step. So tangent of pi over 2 is undefined, so that should be equal to, this whole side should also be undefined, so let's fill in the identity here. So tangent of pi over 3 was root 3. That's this part right here, replaced by root 3. We found that here. Plus tangent pi over 6, tangent pi over 6 was root 3 over 3. That's all over 1 subtract tan of pi over 3, that was root 3, times tangent pi over 6, that was root 3 over 3. So now we need to do some simplification here. I'm going to do that off to the side. So root 3 over 1, I'm putting this over 1 right here, times root 3 over 3 equals what? Well, root 3 times root 3 in the numerator is 3 over 1 times 3 in the denominator is 3, so that becomes 1. So I'm going to replace that whole thing with 1. So now we have on the bottom 1 minus 1. So the left side was undefined, so let's see, the right side would be 2 because we have 1 minus 1 here in the denominator, or 0. So we're dividing by 0. It doesn't matter what's happening up here, we're dividing by 0. So we have proven that both sides are undefined and that that identity works.